All right, so let's get started. Welcome everyone to the Coralogix webinar on scaling observability. Your host, Chris Cooney, with our guest host, Ariel Assaraf, CEO of Coralogix. Chris, take it away.
Well, thank you very much. So hello and welcome to the webinar. Today we're going to be discussing observability at scale. We'll just do a quick introduction about who the speakers are. So I'll just quickly do myself. Hi, I'm Chris. I have been a senior engineer for a while now. I have the grey hairs to prove it, and I have been working primarily with Kubernetes, AWS, and a great deal of other cloud-based technologies to bring sort of resilience and observability to multiple organizations. Ariel?
Yeah, Ariel, CEO of Coralogix, been messing around with monitoring and observability for the last 6 years here.
Oh, so what are we going to talk about today? Today we're going to cover a sort of very, very broad range of topics, but really centered around observability and what scale does to observability and the challenge there. We're going to talk about things like CI/CD. We're going to talk about microservices, scaled architectures, cloud-based platforms, and much more sort of as the conversation leads. So without any more waiting, let's get straight into the meat of it. So thought we'd just start straightforward. We'll frame the conversation and we'll get going. So what is observability and why is it important? It's really, really easy to think about observability as this continuation of approaches that have been going on for a very, very long time. There would be many amongst you that started software engineering a decade ago, and you'll all remember that knowing what the software was doing was just as important then as it is now. But observability has become this word over the past few years that has sort of captured the public consciousness, and it's made people wonder a great deal about what can we actually get out of our monitoring and our visibility solutions. So observability encapsulates a great deal of different metrics, so anything from logging or logging the entire suite of applications that you have in your system through to specific tiny metrics like the CPU usage of a single container sat in a Kubernetes cluster somewhere on the other side of the company. It's become important, quite obviously, because of a variety of reasons, but I think the most obvious thing is we deploy a lot more applications now. The rate of change is far higher than it used to be. A change advice board was a staple of any technology company 10 years ago, maybe even less. And now it's somewhat rarer and rarer to see that. Now autonomous teams make decisions amongst themselves and they deploy ad hoc. This is kind of the model that the industry's gone with, but that increased rate of change has created a much higher monitoring and tracing challenge. And that's kind of where observability comes in. We also encourage engineers not to write in a homogeneous language anymore. Engineers can write in lots and lots of different languages, and this creates a very, very sort of diverse system that is very optimized towards the problem that each service is solving, but also it's doing it in a slightly different way on a slightly different technology, anything from Golang binaries all the way through to JVM running inside a Docker container. It's very, very difficult to keep track of all of that, and that's all wrapped up in the observability challenge. So as technology becomes more diverse, more rapidly moving, and more broken up in these sort of microservices architectures, we become more aware of that. So I suppose the first question that kind of comes to mind is, when you talk about the old style of approach, it sounds stuffy, the word monitoring. What is the difference between monitoring and observability? And I'm really keen, Ariel, to get your view on that.
Yeah, I think that a lot of people mix up monitoring with the observability, or maybe using observability as a fancy word for monitoring. Basically, there's a big difference between them, and I agree, by the way, with the reasons that you mentioned for observability to become a thing, and monitoring with all its problems is only now being replaced with this new approach. One of the reasons, by the way, is that we're seeing that companies are more reliant on third parties, external APIs, and the ability to monitor those areas and understand where problems even start over there is very limited. And so the only way for you to understand what's happening in your production is to actually have the traces and logs coming from all the different transactions and all your different users' actions, and then be able to ask questions. And that's the biggest differentiation between monitoring and observability. The way that we see it here in Coralogix is that monitoring is answering or identifying questions that you know how to ask. So each and every one of us dealing with software is able to tell that a spike of errors or a certain exception or a certain forbidden action in your system is something that you want to be alerted on or view in a dashboard. But these are known things that you just want to track. So you basically set watchers to understand, or you build dashboards to understand whether something deviates from things that you know that shouldn't happen. Observability lets you ask questions on the unknown unknowns. So when a user is failing to perform an action on my payment system, if it gotten to that point, I probably didn't get an alert, or my dashboards didn't show anything, or there's no monitoring system telling me that someone failed or someone is about to fail. So now I need to be able to come in some sort of system or centralized dashboard and be able to ask questions like, what changed in the past hour? What trends am I seeing that are abnormal? What types of logs appeared in that hour, and then what are their behaviors, and whether something changed in how my system typically operates. And then being able to ask these questions and correlate answers from different data sources, if we're looking at matrix or logs or traces, or even security data that we see as part of the observability cycle, is key to be able to answer these questions without having to reproduce the problem, which is something that we see a lot of companies doing. So a lot of companies, whether if it was not identified by their monitoring systems, they need to reproduce the problem now that they know what problem happened, and then be able to observe basically the data flow and understand what happened. And then their next step would be to, now it's not an unknown anymore, they'll add this to their monitoring. And that used to be enough in monolithic systems or even microservices in the beginning. But like Chris mentioned, with the increase of changes, CI/CD, microservices, companies moving to the cloud to scale faster, more stacks involved in my production, more APIs involved, suddenly that chase that we used to do of, okay, let's figure out what happened, and then let's move this into the questions that we constantly ask our system, that is not sufficient. I see a question under Q&A section. So I see a question from Aaron. Does Coralogix work well with IIS? Yes, it deviates a little from our subject, but yeah, basically web server logs are definitely part of the observability cycle. So if we look at the full flow of data, we want to be able to tell a story. And the web server logs are definitely part of that story. So if the user complains about an action that failed or some sort of problem that he had, what I probably want to do is I want to be able to ask a question about this user journey and get the data all the way from the web server, see the first request, response, and then where it was led, and then the application log, and then look at the matrix and how my infrastructure responded to that request, and then look at the trace to understand exactly what transaction was trying to happen. And if something broken or delayed, I want to click that and go back to the log itself and read basically the story. So yes, any decent observability or / logging system to that extent will need to play well with IIS logs, parse them, enrich them, make them smarter, and allow you to both define monitoring on them and also to be able to ask questions. So back to the difference between monitoring and observability. Monitoring is a set of questions that you already know and constantly ask your system. And observability is a set of questions you don't know already, but you are trying to basically question your system to understand what went wrong or what it is that broke. Chris, do you see other things that are worth mentioning in the difference between monitoring and observability?
I think you define the difference very, very well. I think that on that point of why is it important, it's on that topic of scale, right? So monitoring is great when you have one app that does 5 things, because one person can conceivably just keep track of all those things. And if something breaks, no worries. But when you're talking about 100, 200 microservices with very specific responsibilities, all doing lots of different things, keeping track of that's really, really tough. And actually, your point was great. So it's not about knowing which questions to ask beforehand. It's about seeing something unexpected, some emergent property of your system, some new thing, and being able to quiz that emergent property and take it into a much more known space. That becomes immeasurably important when you get into a sort of a decoupled microservices kind of world. So yeah, I do think that the scale really drives the need for observability. The bigger you get, the more less monitoring you need, and the more observability you need is the sort of the dial that I've seen happen a couple of times in different organizations. I don't know if you agree with that, Ariel, but
Yeah, I think observability used to always exist in large scale organizations.
Yeah.
But the thing is, because it was always needed back there I remember my time in Verint Systems, there were like 80 different components with services in each and every one of them.
Yeah.
And then we basically had to collect all the logs and performance data and everything into a single huge system and question it. But these days, it's not only corporates that are working at this scale. Any small company, any 20, 30 people company on cloud can be spinning 500, 600 different servers with tens of different microservices. So observability is now basically a citizen capability, not only for experts, not only for corporates, not only for high-end companies. It's becoming a must for every company that is even starting to scale.
I think that's a great way of wrapping up that slide. I think we'll move on. Yeah, brilliant. So sort of the next kind of question we were thinking of attacking was sort of what impact does architecture have on the observability challenge? So from my own experience, I've sort of seen monolith services rise, fall quite dramatically, microservices becoming this really, really important, really interesting thing. And now, interestingly, you're seeing the monoliths kind of come back again in some organizations like Uber and stuff. We were talking about actually why we've started pushing our microservices back together again. And it's really interesting why they decided to do that. So they obviously felt that the architecture of their system was making something more difficult. So it's interesting to sort of look at why microservices came about. So microservices and sort of things like serverless, containerization, they were all about availability. So I can't scale my monolith. It's one thing, it's very highly stateful. I can't make 2 of them because there's a leader election problem or something. Whereas microservices are all about these small, stateless little things that can just dance between the problem. They can scale up and scale down as they need to cheaply. And so the cost optimization promises, the availability promises, they were really, really compelling, and they drove a lot of organizations to a lot of success, to be fair, and very, very powerful architecture. But as time goes on, as you scale that microservices model, you start to get forced to ask some very, very difficult questions, like what are we going to do with all this telemetry data? We have 250 microservices, and they are all absolutely firing out data. So recently, for example, I was having, we installed Istio as a Kubernetes service mesh onto a cluster with 150, 160 different services on there. Not a big Kubernetes cluster by any stretch of the imagination. You know, Kubernetes clusters at the moment, I believe, they're load tested with something like 10, 11,000 pods on them. So this was small stuff in comparison to what Kubernetes cluster can handle. But many of the open source tools that were rendering out that data, they either ground to a halt or they became almost unintelligible. They're just all the lines going absolutely everywhere. And it was a very, very interesting kind of thing to see, because if we had fewer services on there, it probably would have been a lot more interesting, a lot more consumable, a lot more useful, which we'll get onto a little bit later. But I think the microservices then fed into serverless, obviously, or they kind of morphed into one another nowadays. So things like AWS Lambda functions and the sort of comparable offerings from Azure and Google, they create this idea of don't just have a small service, have a really small service. In fact, have a function as a service, a teeny, teeny, tiny little bit of code. And those architectural decisions, as you can see in the diagram, they create these sort of slightly more sprawling sort of architecture diagrams. So where once you had 7 or 8 boxes linked together by a few lines, now you've got, you know, small organizations like Ariel mentioned before, 30 people organizations will end up with hundreds of AWS Lambda functions as they build new features. And they're really easy to spin up. That's the whole point of them, is that availability thing. So you can just fire them away, no problem. So I think that the really sort of interesting thing to take away from that is that while we've gone full on availability, scalability, that kind of thing. We've pushed up against that observability challenge. I don't know if you've got any views on that, Ariel, yourself.
Yeah, I think, two things here. One is microservices and serverless allowed you to scale further than the max that the monolithic apps allowed. So, naturally the problem of observability is bigger, but definitely I agree with you that it's more distributed. It's more formats, by the way. It's more different data types to digest, and it's much harder to get them all together on the same dashboard. So the dashboarding concept of the past monitoring is not sufficient anymore. Also, serverless computing left us without the infrastructure monitoring part, which used to give us like a nice baseline of what's happening, CPU and memory and threads and basic stuff that gives you a very distinguished understanding of whether something really bad is happening. Yeah. But suddenly now with serverless, we lost that capability, and all we're left with is the tracing and the logging part that are less structured, and less structured stuff or less visualizable, I'd say, or less easy to understand for everyone, and that creates a need for expertise inside the organization to know how to read those traces or logs and so on. And then the ability to create a solid observability platform or culture inside the organization that knows how to ask questions without being familiar with the data, with its structure, or what it should say, allows organization to scale, because now you don't have like 3-4 experts that every incident ends up by asking them what to do. You have an organization that uses the sources of truth of their data as these experts. And instead of asking humans, hey, what's this error? Should it happen now? I can now ask my system that same question and get straight answers. So that's where you want to take observability, and that need is very much increased now that a lot of the easy to read type of monitoring capabilities are not present anymore.
Yeah, and just to sort of build on that a little bit, there's another thing that software architectures do to engineers, but also to operational people, is that they incentivize certain behaviors and they disincentivize other behaviors. So if you've got a big monolithic system, it kind of, the traditional fear, right? I don't want to touch anything, but it also really drives you, okay, I'm going to monitor everything. Everything's getting logged. I'm going to track every single thing. I'm going to make sure nothing goes wrong. It creates a great deal of stress, for lack of a better word, in my experience anyway. And that drives a need for, okay, we're going to really go all out on the monitoring here. But microservices architecture, there's this attitude of, especially with serverless, but also with containerization and Docker, even if you run the Docker images yourself, the amount of times I hear the phrase, it's just a Docker container. It's just a Docker container. The Docker daemon will run it. It's no big problem, But that incentivizes the behavior. Okay, we'll just spin up more. But it's just a Docker container, no worries. And if we need more, a new VM is going to pop up. Amazon will spin up an EC2 for us or whatever. And that incentivized behavior also works against the observability challenge. The observability challenge is all about trying to be a bit more careful and just, okay, we need to move at pace. We need to track things and expose metrics. We need to think about that up front as a first-class citizen of our software architecture. But also we're just firing out new services left, right, and center every time a new feature comes up. Bearing in mind, one feature could equal 50 microservices, or it could equal 50 functions as a service. And so I think there's it's quite an interesting sort of psychological impact of having these microservices architectures and what it does to the engineering teams and the sort of product focused teams that are.
I think you touched a very good point here about how monitoring used to happen after you deploy. Yeah. So monitoring used to be, okay, let's create an app, let's put it in production, and now let's start monitoring it. Yeah. And observability goes back all the way to the data that you expose as you're creating these applications. So it starts way, way earlier, and that'll lead us, we'll talk about this later in the slides, to how important is the understanding of the need of observability. This is why we're talking about this so much here, and the need for a cultural change that leads to observability scale. Because it's not dependent on a few professionals now that are good at monitoring. They get an app, whatever the app situation is, and they monitor it. Now it's all the way from the very beginning of planning and creation. How do we surface up? How do we propagate observability from all layers so everyone can understand what's happening once we go live?
Yeah. How do you think that the sort of you know, a while back, you know, we built things on premise and we were very, very in tune all the way from the actual hardware installed in the data center through to the software running. What do you think the cloud's kind of done to that observability mentality? You know, and now it's so distant from the actual sort of implementation of it.
It's a good point, actually. So specifically when you look at serverless, you see that a lot of times the idea of just creating a function and let AWS run that for you,
Yeah.
or Google or Azure, made people a lot less mindful or minded to performance, to quality of code, to documentation, to logging, because they're out of the context of writing code or functionality. Now they're just writing a script. And it's a lot about the medium where you're at, the attention that you give. When you're writing a Lambda function, it feels like a patch script sometimes and just takes you out of the context of quality. And so again, getting that culture in, that helps people understand the importance of at least externalizing the parameters and logs and other things that are important to people that are going to basically maintain that in production. And we'll talk about also the shared responsibility model here. That is key to achieve stability and high performance.
I think that just to add to that, you know, even before sort of Lambda functions and serverless and all the really new flashy things, even when VMs first came about, you know, people are, oh, I can just have one of these things. I used to have to wait 2 weeks. And all of a sudden 100 of them appeared because the devs could, you know, and there's a certain element of once you have the tool, you're very, very keen to use it. If all you've got is a hammer, everything starts to look a bit like a nail. And so the this sort of the ease of use and the sort of lower cost of being able to spin up a server and only pay for the time you use it is an incredibly powerful availability tool. But it like I say, it sort of contributes to that observability challenge. So one of the things that just came to mind was a team that I worked with who every morning at about 6 a.m. they had very predictable load profiles. So they looked at their sort of performance metrics and they'd seen that about 6 a.m. the traffic starts to spike, gets really, really big at about midday, and then by about 8 p.m. it's kind of tailed off. And so what they were doing was on time base, of just scaling up. So, but they didn't have the observability thing down, right? So their monitoring was saying, you know, 7 nodes, because they were counting 7 nodes, right? Well, what they didn't know is that 3 of those nodes couldn't talk to the 4. They had no idea. And so it wasn't until they'd implemented a sort of caching solution that was shared across all the nodes that all of a sudden they were like, whoa, we've got a cluster of 4 and a cluster of 3. What's going on there? And they were completely separate networking groups, but they didn't know that, and they'd just done it, and some guy put the Terraform together. And what I found really, really interesting from that was that they'd made this sort of high-level feature decision. They'd highly optimized the feature of their architecture, but they didn't have that observability capability, and they suffered for it in production, which is a very, very, very interesting sort of offshoot. And a real sort of, it's very rare that you get those sort of classic case studies of like, if you'd been able to ask any question you want up front, it would have been a bit of a different story. But yeah, so I think we've definitely established that architecture has a massive impact on the observability challenge, and slight lamenting of the death of the monolith. Although the more I see I see slightly edgy blog posts coming out these days of how we freed ourselves and went back to the monolith, and I kind of help but wonder, like, how much of a monolith is it really? Like, but yeah, how many of you were actually doing the monolith stuff when they were cool? So yeah, have you got anything to add to that, Ariel, or is there? Are you happy to?
I think we've covered that.
Awesome. Yeah. Okay, so the behavioral changes. So this is kind of the organizational, but also the inter-team and intra-team kind of decisions that have to be made as you're scaling it, so you can preserve a culture of speed, moving at pace, and CI/CD, but in order to maintain observability, so that pace is safe and you're moving in a sensible way. So I'm really, really keen to hear what you think about that, Ariel.
Yeah, so we've seen so many different models with clients that we work with, and try to gather some of the key things that we saw that helped companies become successful. Um, so one thing that started quite together with observability is the idea of SRE engineers, people that are doing site reliability. And I think that that was mistakenly taken, and these guys are used as basically people who are NOC engineers. People see SRE as people who monitor the system. So what an SRE does, he looks at the dashboard, and if something goes wrong, he operates the runbook. But um, the idea of an SRE is just to become a moderator or someone who is implementing the observability and the stability culture into the organization and helping the organization scale that. So just like having a collaboration manager doesn't make your organization collaborative, having an SRE engineer doesn't mean that you have an SRE culture or observability or good practices for system stability and performance. The idea is that the ownership should come back to the R&D teams to have specific feature owners and product owners that understand the different services. And they're responsible as part of their definition of done to make sure observability is baked into the product and helps them actually scale that product. And it should be readable and coherent enough so that people monitoring it and taking it to the next step of scale are able to use those tools that they baked into the product. But these guys will always stay a focal point for the SRE as they monitor, observe, and scale that system to route them through what needs to be added in terms of data that needs to be collected to get the full picture, what needs to be monitored, and what are the pitfalls that they should avoid. And then whenever there's an issue, it's very important for these guys to be able to host and moderate a blameless postmortem. So whenever a service has an issue, the team needs to be aware of the fact that something went wrong, what it is that went wrong, what it is that went right during that issue, and what action items should be taken in order to improve that. An action item, again, is not only adding that very same scenario, that question that we know how to ask into our bucket of alerts or dashboards, but it's also understanding what data points were we missing when this started to understand the issue before it arose or to solve it faster. And then it all depends on the sources of truth that your organizations create that helps you create that data-driven discussion where people only discuss facts, data, and things that they've seen and don't take it to a more of an objective type of subjective type of opinion or more of sometimes emotional type of discussion. So once you standardize the way that data has been being written into your data collection and data presentation layer, once you define some kind of unified platform that allows both autonomous teams to decide how they want to track, monitor, and observe their systems, but also the SRE teams and the platform teams to enforce standards that are a must, whether it's on the definition of done, deployment to production, monitoring, observability, and postmortems and other improvements that we do after we go to production. If you're able to let the teams build their responsibility around that feature owner, the way that they believe that this feature should be monitored and observed, and then it passes the standard that the platform and SRE teams define. And then whenever there's a glitch, the team is able to learn from that, add the relevant data, and improve. That is the cycle that lets you quickly scale and have your services become more stable and more performant as you grow, instead of the classic case of services being stable, and then as you scale and grow, becoming more complex and less stable.
Yeah.
Anything you want to add, Chris, over there?
Honestly, I just had a question based on your experience, really. I know for a fact there'll be some people watching, and I myself was one of these people at one point who were in organizations where feedback wasn't that easy to come by. Why obviously it's super important for sort of scaling up and maintain a culture is to have that feedback cycle. If you had some advice for someone who was really looking to try and instill that feedback culture, both from a leadership and a sort of engineering perspective, is there any sort of pieces of insight you've got there?
Yeah, so I think any feedback should be, first of all, constructive in terms of how do you convey a message, but also needs to be data driven. And then the feedback loop that is based on the data, the automation that you create needs to surface issues and specific data points that are relevant all the way back to the service owner, who needs to be aware of that. And then he needs to feed the SRE team with the feedback that he's getting from his telemetry in production, so they can build the next step of observability and monitoring for that service. And then the manual part of the feedback loop is done on postmortems, because there's always going to be some kind of loophole. There's always going to be something that is breaking, or something that we thought that we have observability into, but we don't. And then you do that postmortem analysis, again, based on the data, based on source of the truth, and you improve the things that were unknown and that the service owners were unable to get feedback from production. So whenever there's missing feedback, it means that there was missing data that the system was not sending or was not displaying. And then we fix that, and the feedback loop improves. I hope that answers the question. I'm not sure that I...
Definitely. I think the only thing I'd add on to that is that, that one of the key behavioral changes that I kind of see in more mature organizations is the attitude to failures. In some of the more traditional organizations I've worked, their idea is we're just going to make it so failures never happen, and our monitoring is going to be there to make sure failures never happen. But obviously, monitoring specifically is very after the fact, and so something must have happened for you to be spending so much time looking at your monitoring in the first place. And so when failures do happen, blame is the natural thing. But even if you get past the blame, it's seen as such a negative event that people kind of just want to get past it. And they're like, we lost a bunch of money, or we had a bunch of downtime, our customers are really unhappy. Let's try and, let's just be great going forwards, and that's cool, and let's forget about this and put it in the past, kind of thing. The dysfunctional family approach to improvement. Whereas I think that a mature attitude towards failure is something's going to go bang at some point, something's going to blow up, and the best thing that we can do is invest in the future, be as prepared as we can be to ask the questions of our system. Right, requests aren't making their way through. Where's the failing bit? You don't have to say, is this service failing? Is this service failing? Is this service failing? Your traceability solution will say, for some reason, stuff isn't getting through this thing. You go, cool. You look at your logs, you look at your metrics, you can go, CPU's through the roof. Cool, right with that, And that attitude to failure, I think, is such a key part of the feedback process, right? Because something breaks, it's like, okay, that was rough, but we're all in this together. We knew it was going to happen. How do we fix it? How do we improve? So I think that sort of embracing failure is such an important thing.
And that goes all the way to the C-level in the company. So that should be a culture that is led all the way from the CEO, CTO, down towards the engineers, because it's very hard to operate in a blameless environment as a manager or an engineer if you know that your managers are stressed or looking for someone to blame or asking you problematic questions. Like, if your CTO or CEO is asking after a crisis, whose fault this is, it's going to be very hard for you to implement a blameless culture, because, and the right answer, by the way, is it doesn't matter. Like, we're all in this, and we missed this data point, and now we fixed it, so this doesn't happen again. Yeah. I think that's a very good point that you brought up there, Chris.
Do you think that we talked a little bit about the behavior that needs to happen for observability to come about, but once you really start nailing the observability function, do you see any sort of feedback that comes from that? Did you see any cultural changes that happen once people get a bit more confident in their observability stack?
I'm not sure I understood that the actual question here.
So what we're talking about here is the behavior you need to do in order to enable observability, the kind of things you need to espouse. But once you've enabled observability, does that strengthen some of those behaviors you've put in place? Does it? What are people's attitude to risks, that kind of thing?
Yes, it's definitely a snowball, by the way. Like the moment you do that first successful feedback loop and postmortem, people feel so confident afterwards that they'll initiate the next one. So you want to get to a point basically where a failure happens and a service owner jumps and says, hey, it's my service. I want to initiate a postmortem so this doesn't happen again. So I think that you just need to give confidence inside the organization that it's okay to make mistakes. It's okay that if something breaks, if we just fix it fast and work together towards a better system. It's definitely something that at the beginning might be more difficult, and then you just need to go by rules. We don't say this, we don't say this, we only go by data, we only go by this source of truth is the only thing that we search for in order to show facts and share them with the team once there's consensus about that data source. But once you get through and past the first ones, it's basically becoming a part of the company culture. And then the great thing about it is anyone joining the company will enjoy that so much that he'll immediately become a part of that blameless culture and data-driven culture.
Yeah, definitely. I think one of the best examples I saw of that was I walked into the office. It was 2:30, 3 o'clock. It was a small company, and they great CTO, just fantastic guy, and everyone was drinking. And I was like, what's going on? Like, we're in England. I understand it, but this is a bit early. And they, what did he say? He goes, well, we had an outage. I was like, okay. He's like, yeah, but it only lasted for 6 minutes and the system fixed itself. So we thought we'd have a party. And I was like, okay, fair enough. That's pretty good, actually. Yeah. And it turned out that they'd had a sudden spike in traffic. The autoscaling had kicked in, but because they'd done some really good performance testing regularly, but a few days beforehand, and they'd ironed out some tweaks in some of the bottlenecks in the system early on, and they'd done that due diligence, it paid off straight away, immediately. I thought that was a really fantastic sort of way of, the guy was celebrating the success of the recovery, not the initial, the 6 minutes of disruption. Bearing in mind, the sort of State of DevOps report in 2019 described the elite performers, the very best performers, as recovering within 1 hour. And so if you're underneath that, you're doing well. Definitely. So,
and I agree. And the reason that you're mentioning that, that culture and everything and all that company, and you start with the CTO, is because it's the C-level that needs to make sure that they're the best representatives of this type of culture.
Definitely. Okay. I think we've covered that topic quite well. Do you want to move on?
No.
Are we moving? Okay. Yeah. Sorry. Okay. So we've talked about behavior. We've talked about the actual sort of nuts and bolts of all this. Let's imagine for a second that we've got this observability system. We've got a great stack. The CPU's absolutely fine. It never clips above 50. We're wasting money. We've over provisioned, but we never have any worries about it. RAMs, we have more RAM than NASA. It's going great. We can network bandwidth, download movies in 30 seconds. It's fantastic. But is there more to it? Is there more we should be focusing about? I'd be really interested to hear what you think about that one.
Yeah, I think that when you rely on infrastructure monitoring, you are probably only seeing the very big problems that are very acute, but you're missing out on a lot of the issues that are hidden in your logs and traces. So just a simple example, if I have an e-commerce website and 2% of my customers fail to buy, which is horror, I'm not going to see that in any of the infrastructure metrics. So I would suggest two things. First of all, obviously logging gives you the full story. Logging is the diary of your software. It gives you everything that happens. It lets you ask any question you like. It lets you look at the data aggregatedly or on a single user action, on a single journey. But also matrix can be smarter than infrastructure matrix. So when you do proper custom matrix that actually cover your business logic, when you label them properly, then you're able to catch a lot more. So if you label a matrix called failed purchases or purchase numbers or amount of time to transact a purchase, and then you label this by user ID, country, city, web page, whatever, you're going to get a much better view from your matrix data. And then from there, you should be able to drill down into a specific point in time, whether a specific user ID in your tracing or a specific time frame for your logging. So definitely the old school approach of infrastructure monitoring will give me a sense of what's happening is okay if you want to understand that critical stuff happened, but definitely not the right way to serve people in today's era when people are not very forgiving for software issues or latency or tiny bugs that can be super annoying. So these stuff will never be identified with CPU or RAM. The thing is that to collect all the rest of the data, custom matrix and traces and obviously logs, it's just overwhelmingly expensive. And so companies trying to get that full coverage that we're talking about, many times they face an issue of saying, okay, so I collected the logs and traces and matrix from everywhere, but now the cost of monitoring is becoming unbearable. And that is something that we've seen across the board with so many clients. And that led us in Coralogix to start thinking of a solution that will stop looking at data as a single unit and log data or matrix or tracing as single unit, and basically triage data into 3 different routes depending on what it is the customer wants to do with that data. Yeah, so this map shows a nice illustration of how we triage data. Basically, the top one for frequent search is your observability component. So this is where you ask these unknown unknowns. So everything goes there. Everything is ready for you to query, visualize anything that you want to do with the data. It's a small portion of the data, business-related data, errors, warnings, critical logs, user data, things that are very specific that when they go wrong, payment data, obviously, you want to be able to question any question you want, slice it anyway, super fast, super efficient, create dashboards on the fly. Then the second tier is monitoring. This is all the data that you know what to ask. So the known unknowns. So you want to view it in real time in your live tail. You want to parse it. You want to create dashboards. You want to get anomalies if something strange happened. You want to receive alerts on predefined configurations or dashboard or thresholds or dynamic thresholds. But once you get them, you already know how to operate because these are questions that you knew how to ask. So you know already what to do. And then only in rare cases it is that you need to rehydrate that data. And then you go through the route of re-indexing or querying the archive directly to continue your investigation. And then there's the route of compliance. There's so much data that is never queried, never visualized, never alerted, but it just needs to be there for compliance reasons or just in case someone will complain that last month they haven't done a purchase, but they got charged. And so that data is not something that you want spamming your system, interfering with your investigations and questioning of really meaningful data, and not even monitored. And so you just want it stored somewhere and be able to rehydrate or query it from your archive whenever something comes up. And that triage also propagates itself to matrix data, where we allow different granularity for each and every one of your matrix per environment, per service, and also the tracing, where you can sample and not do the full trace on everything. And that way, reduce costs, reduce clutter, and use the data the way it should be used and pay for data the way it should be paid. So basically, the less you need that data to be hot and analyzed in real time, the less you pay for it. And that leaves you to the point where you pay an aggregated price of 30% of what you used to pay for the data that goes full process, which in turn, not only doesn't hurt your coverage, but it all actually increases your coverage. Because now financially, as a decision maker, DevOps team lead, backend team lead, SRE engineer, you're able now to get full coverage of your environment for logs and matrix and tracing and security, and be able to understand or ask any question you like, or monitor anything you'd like, or be compliant with any standard you'd like, without breaking your budget or making compromises of systems that you can't pay for monitoring. So a classic use case, by the way, we're seeing is that, ELB, NLB, Akamai, all the web server logs, basically, a lot of people tend to neglect them because they create a lot of noise, a lot of clutter, and they're so expected that there's such a limited set of questions you can ask there that you can easily route all the 400s, 500s through the frequent search part. If something goes wrong, monitor all the rest. So visualize their behavior, view like labeled URLs and their behavior, visualize an alert on latency, on slow responses, and so on, or suspected IPs, but still not keep the entire data set, or just decide to drop it because it's too expensive. So that's the idea of triaging data in Coralogix Stream, a solution.